In our last example, we had the function f of x equals the square root of 1 over x minus 3, and g of x equals the square root of x, and we found f after g of x. And as you can see there, we have the domain of f was everything from 3 to infinity, not including 3, and the domain of g is everything greater than or equal to 0. So in this example, we're going to find g after f of x, and of course that comes with a specified domain. So let's find a formula for it first. It's g of f of x, and so that's g applied to the square root of 1 over x minus 3. So it's the square root of that, so it's the square root of 1 over x minus 3, or the fourth root of 1 over x minus 3. Now remember, the domain of g after f is everything in the domain of f, so that I can apply g to f of x, so that f of x is in the domain of g. And so that's every x in the interval from 3 to infinity, for which f of x, which is the square root of 1 over x minus 3, is in the domain of g, which just means it's greater than or equal to 0. Well, this is always true for a positive number. Its square root is always greater than or equal to 0, so there's no restriction here if this comes from the interval from 3 to infinity. So that's just all x in the interval from 3 to infinity, and so our domain is everything from 3 to infinity. What's g after f of 16? Well, I can use the formula. 16 is certainly in the domain, and g after f of 16 is just what I get when I plug this into the formula. 1 over 16 minus 3, and that's the square root of 1 over 13, and so that's 1 over the fourth root of 13, and that's not even remotely like what we got when we calculated f after g of 16, which turned out to be 1. So the important points about f after g and g after f is you can find a formula for them by applying them consecutively. You must be careful, you must specify the domain because of how you've constructed the function. And also, you must note that g after f is not the same function as f after g. This is not a commutative operation on functions. Also, it's very important to recognize composition of functions, and this of course will be very, very important in calculus when we get to the chain rule. So in order to differentiate something like this or work with it, we have to break it down into a composition of functions. So here's a function, x cubed plus 2 to the 7. We're given the formula for it, so the domain is not specified, so it's assumed that its domain is the set of all x values where the formula makes sense. And suppose I want to express it as a composition of two functions f and g, then I have to do a little guesswork here. So we work from the inside out. So we're looking for f and g, which is f of g of x, and we would like this to be equal to x cubed plus 2 to the power of 7. Now, working from the inside out, we have x cubed plus 2 inside the brackets here, and if we apply the power function, where the power is 7, to that, we get our final answer. So one good guess is to let g of x equal what's inside the brackets here, x cubed plus 2, and let f of x be the power function x to the 7. What happens when I calculate f after g of x, and I'll check, that should be f applied to g of x, that should be f of x cubed plus 2, and that's equal to x cubed plus 2 to the 7. So bingo, that is indeed the answer. Now the domains of both of these are everything from minus infinity to infinity, and also the domain of f after g is the same thing, which is also the domain of this. There are no restrictions on calculating this. So I've expressed this function as f after g, a composition of functions. Try this for the next function and then have a look at the solution. Here we want f and g so that f after g of x, which is equal to f of g of x, is equal to the square root of x plus 4. Well, notice this is the square root applied to x plus 4. So a good guess would be g of x equals x plus 4, and f of x equals the square root of x. What happens when I calculate f of g of x here? I get f of x plus 4, which is the square root of x plus 4, and that is true. And you can check that the domain of this function is all x greater than or equal to 4, greater than or equal to minus 4, and this is also the domain of this one. So we've broken this down into a composition of two functions.